So quick intro reactions overview balancing kind of question sort of thing here, right? So let's look at this reaction and see what it's telling us, right? It's telling us our sulfuric acid, right? Remember when things start with H, if it's not water, that's going to be an acid for us. It's dissolved in water like most of our acids are. So this is sulfuric acid. Is going to react with potassium hydroxide. That's a S right there, so that's telling us that's a solid. When we see hydroxides like that, right, that's a base. Acids and bases neutralize each other, so this is an acid-base reaction. Those are going to make water and a salt kind of thing. We have liquid water, right? The L there shows us that's a liquid, and then our potassium sulfate is aqueous, right? So if I want to balance this thing, let's go ahead and balance it in blue. I can't change any of these formulas, right? The formulas are there based on charges. Sulfate is -2, hydrogen's +1, right, from our valence electrons and periodic chart. So it has to be H2SO4 based on charges. But I need all the atoms to balance because of law of conservation of mass. So I can change multiples of things, right? So remember our rules. Don't start with hydrogen and oxygen. If a polyatomic stays the same on both sides of the equation, you can balance it as one thing. So I see sulfate. There's one sulfate right here. So I'm going to balance that like it's one atom. And I'm going to ignore the sulfurs and the oxygens for anything else. And I see sulfates over here, and that is 1 also, right? I could have started anywhere, but, well, besides lone hydrogens and oxygens, that just makes it harder. Right, so then I'm going to go to potassium next. There are 2 potassiums over here and only 1 potassium over here. So I'm going to fix that right away. There's 1 here right now, but I want there to be 2. So that we match over here. So that means I'm going to put a 2 out in front. I can't put a 2 in the subscript spot because that would change my formula. And hydroxide's -1, potassium's +1, so it needs to be a 1-to-1 ratio. But I can get 2 potassium hydroxides. I just need twice as much potassium hydroxide, right? Then we look from there and we say, well, I don't have any other polyatomics that stay the same, so let's just look at our hydrogens, right? So I have 2 hydrogens here, plus 2 more from here. That's why we like to wait on them for a little while because they're in multiple places a lot of times. So 2 hydrogens here, 2 hydrogens there, so that's 4 hydrogens total. So I want it to be 4 hydrogens over here also. Well, right now I have 2, so I'm going to put a 2 here, and that gives me 4 hydrogens. That gives me oxygens. Now, I'm not going to worry about the oxygens that are in the sulfate because I already accounted for those. So I have 2 oxygens. Again, I'm not going to worry about the oxygens over here because that are with sulfate. And hey, look at that. I have 2 oxygens. So I leave hydrogen and oxygen for the end because they tend to balance themselves. So to finish this off, we should put 1s here so that we know that there's 1s there. It's again, chemistry is a little inconsistent in some spots. We don't want a 1 there because it's an understood 1. But when we balance, we like to show there's a 1 there just so that we understand there's a 1 there. It's not really wrong if you don't, but it's at least at the beginning, do that, right? Let's do a second one here. So here's the second equation. I've got propane, right? That's like propane in your grill, and oxygen react to make carbon dioxide and water. Notice I didn't put any states on this one. You don't really have to have the states to balance, but it does tell us more about it. Propane is a gas, oxygen's a gas, carbon dioxide's a gas, and when it's hot, like it would be in a barbecue grill, water's a gas, right? So all of these would be gases if we wanted to put that in. Same thing as before. Let's do an atom inventory. I'm not going to start with hydrogen and oxygen. I'm going to start with carbon. That's the only other element. There are 3 carbons on my reactant side. So on my product side, I have 1. This 2 only goes to the oxygen. I have 1 carbon here. I want 3. So I'm going to say, well, put a 3 right there. That gives me 3 carbons. Then we look, well, what's next? Well, I could do hydrogen or oxygen, but I see oxygen in 3 places. Hydrogen's really only in the 2 spots. So hydrogen's better here. So we have 8 hydrogens here. Well, that means I want 8 over here. I don't have 8. I have 2 right now, but I want it to be 8. So what I'm going to do is I'm going to say, well, how can I make that 8? Well, I'm going to do a 4 right there, right? Or I could have written down, 2. Well, I need 4 of. I need to multiply it by 4 to get to 8, right? So we have 8. That's probably a better way to write that out, actually. So now that since oxygen's in multiple places, we definitely want to save that one for the end. We're at the end now. So I have 3 times 2 for 6 oxygens plus 4 times 1 for 4 oxygens. So I have 10 oxygens. Again, 3 times 2 gives me 6 for my carbon dioxides. 4 times 1, right? I multiply here, and then I add those 2 together. So we had 6 plus 4, so I have 10 oxygens. Over here, we've got 2 right now. I want 10. Can we Dora the Explorer this? Can you go get a backpack or a map or something and tell me what to do? I bet you know what to do. I have 2. I want 10. I'm going to put an 8 right here. No, it's not plus, it's times. So it's not an 8, it's a 5. It's a 5, that's right, it's a 5. See, you help me out with that. We can build it together, Bob the Builder. Right, so 1 propane and 5 oxygens make carbon dioxide and 3 carbon dioxides and water. This is complete combustion, right? It's a little side thing, not about balancing. Let's say you don't give it enough oxygen. If I don't give it enough oxygen, I can't make enough carbon dioxide, right? That's the dirty flame kind of thing, right? So if I burn, now this is a butane torch. This would be C4H10. But if I cut off my oxygen, right, there's less oxygen. It's not getting enough oxygen now. So instead of making carbon dioxide, it makes free carbon, right? So we get that free carbon, then does some black body glowing and glows that yellow color, right? Because that's not getting enough oxygen. So it wasn't balanced, and it wasn't able to make the carbon dioxide like it wanted to. It was just making free carbon.